Welcome back. So we're going to be learning about trig ratios. So you learned a whole lot in geometry about trig ratios. Now we're going to learn a whole lot more. All right, so trigonometric ratios, the fundamental trig ratios are sine, and we just abbreviate that SIN, cosine, which is abbreviated COS, tangent, which is abbreviated TAN. Angles are usually named with the Greek letter theta. So you'll see these as sine theta, cosine theta, tangent theta. You have to have a variable. You have to take the sine of something, the cosine of something, the tangent of something. That's just telling you find the ratio for that angle. So like you have to multiply two numbers. You can't just have a multiplication symbol just floating around, right? Yeah, you can't just have sine, cosine, and tangent. They're operations. So the ratios depend on which angle you are calling theta. Theta will never be the right angle. It has to be one of the acute angles. So it's always one of the acute angles. All right, so you know the side opposite the right angle is called the hypotenuse. The leg opposite theta is called the opposite side. Makes sense. We learned this last year. And the leg that touches theta is called the adjacent side. So if that's theta, there we have labeled the hypotenuse, opposite side, and adjacent side. So we're going to do a little review of just those vocabulary words. All right, so there are two possible angles that can be called theta. Once you choose which angle is theta, the names of the sides are defined. You can change later, but then the names of the sides also change. So if we want the other angle to be the reference angle, we want that one to be theta, right? Now, the hypotenuse is still the hypotenuse, but now the adjacent and opposite have switched, right? Because which one is opposite and which one is adjacent to that angle is different than for the first angle we looked at. By the way, there isn't anything to write in your notes yet. This is just review. So now you're standing at angle K. Label the opposite, adjacent, and hypotenuse. All right, so hopefully you will say that the green side is the opposite. And you will say, we can make this color-coded, the purple side is the adjacent. And oh, now I have to find pink. Oops. Oops, and well, I can't because I have a box that shows me how long I've been recording. You can't see. Well, I don't know. No, I don't think you can see the recording box. So pink is, of course, the hypotenuse. Ooh, that's a little too light, huh? I guess if we want to use pink, we better use a darker shade of pink. I don't have a darker shade of pink. All right, well, it's red then. The hypotenuse. So much for color. All right, now here we're looking at angle K, which I have no idea where angle K went to. So let us call this one here angle K. Right? So if we wanted to know the opposite, hopefully you would tell me the red side is the opposite. Hopefully you would tell me this lovely teal side here is the adjacent because it's touching angle K. Oh, can I write in yellow? Not that shade of yellow. Maybe we'll take this kind of darkish yellow here. And then, of course, opposite the right angle is the hypotenuse. Right? Oh, look how pretty. It matches. All right, so hopefully that's all review for you, which is opposite, which is adjacent, which is hypotenuse. So you learned 3 trig ratios. We're going to learn a few more. And we're going to learn 6, actually. 3 review and 3 new. Now at the very top of the page, you might want to add this into your notes as a little reminder how you solve for angles, right? And sides. Actually, these are, angles and sides here. So I'm going to go over these and let's have you put these in your notes. There's room on top there. So you have a triangle there, which has adjacent, hypotenuse, and opposite these in just as a reminder. Here we have the blue triangle. And we have a 40-degree angle, and I know the adjacent side. Right, this is adjacent. And we're looking for the opposite side. All right, so remember, we were tangent, if you remember, so, ka, toa. tangent was opposite over adjacent. So if we wanted to solve for our opposite side, we could set up the tangent ratio. So then actually this tangent ratio for a 40-degree angle. So tangent 40 is equal to x, the opposite side, divided by 10, the adjacent side. And then we would just isolate x. So in this case, we'd multiply both sides by 10, and then you plug that into a calculator. Or remember, we had the table of values that gave you all of the ratios for the different angle measures. Right? But you can easily plug this into a calculator, multiply 10 by the tangent ratio. There's a bug, by the way, flying all around me. And so I'm trying to swat it. Times the tangent ratio for a 40-degree angle, and that would give you 8.4. Next to it, same triangle, right? But what we know is a little bit different. And well, actually, it's only the same in the fact that I used a 40-degree angle again, but nothing else is the same. Because you can see now that adjacent side is a different measurement, right? And it's not exactly the same triangle. Right, so here we know we're looking for the adjacent. We know the hypotenuse. Which of our trig ratios uses adjacent and hypotenuse? So cosine, adjacent and hypotenuse. Right? So COTA. Right? So if we take the cosine of a 40-degree angle and set that equal to the adjacent x over the hypotenuse, 15. Now we just need to isolate x. So we just multiply both sides by 15. We have 15 cosine 40 equals x, and you can just plug that into your calculator. So 11.5 is equal to x. The last one here, I'm showing you an angle. All right, so now we're looking for an angle measure, not a side measure. We know the opposite and the hypotenuse. So which of our trig ratios uses opposite and hypotenuse? Well, that was sine. So opposite and hypotenuse. All right, so we have sine x is equal to the ratio of 10 over 15. Now we just need to solve backwards to find out which angle measure has a ratio of 10/15. All right, so now the inverse of sine is arcsine. Right, so it's that -1 there just means you're going the opposite direction. Now we don't have the angle. What's the ratio? It's now here's the ratio. What's the angle? So the arcsine and sine cancel their inverses. So we have x, and if you take the arcsine of 10 divided by 15, you find out that that was a 41.8-degree angle. So that's a little review from geometry. Write that in your notes to remind you. If you don't want to put it on that page, you always put on a separate sheet. Now let's go over all the primary trig ratios and the reciprocal. Reciprocal, remember, just means you flip them. Right? So they're the same ratios flipped. We have sine, which is opposite over hypotenuse. The reciprocal is cosecant. It's abbreviated CSC, and it is hypotenuse over opposite. We'll talk about why there's R's and Y's and X's there later. All right, that's in your notes already. Actually, oh no, that's that part's not. So you might want to put the Y's and the R's and the X's in your notes. I don't have that part in your notes. I have the ratios. It's not super crucial, but it might be helpful later. Cosine, remember, is adjacent over hypotenuse. Its reciprocal is secant, abbreviated SEC. And that would be hypotenuse over adjacent. And then the last primary trig function is tangent, which is opposite over adjacent. Its reciprocal is cotangent, which is adjacent over opposite. So they're the exact same things, just flipped the reciprocal. Right? So now you know all 6 trig functions, and that's all there is. So now we're just going to be finding some ratios of trig functions. Super easy. All right, so here we want to find the 6 trigonometric ratios for the angle theta. Always first thing you need to do is label your sides relative to your angle. 5 is the opposite. And this one is in your notes, so label that opposite. And then next to the angle, we have the adjacent. And of course, opposite the right angle, oops, I'm writing right angle, is the hypotenuse. Right, so now we're just writing our ratios. Right, so I already have opposite, hypotenuse, all that listed for us. You don't need to write that part again. You have it right above on the page. You can just write sine and the ratio. I have that there for us so that we can review what the ratio is. All right, so sine theta is opposite over hypotenuse. Opposite is 5, hypotenuse is 13. So it's going to be 5 divided by 13. By the way, if these reduce, we should reduce them. These don't happen to reduce because 5, 12, and 13 don't have any factors in common. Cosine is the adjacent divided by the hypotenuse, so that would be 12 over 13. And you will leave these as fractions in lowest terms and rationalized if need be. Tangent is opposite divided by adjacent, so that's going to be 5 twelfths. And now we get to our reciprocal functions. So cosecant is the reciprocal of sine. It's hypotenuse over opposite. And so we just flip the 5/13ths and it's 13/5. Secant is the reciprocal of cosine. And so now that would just be hypotenuse over adjacent, or 13 over 12. And then cotangent is the reciprocal of tangent. So it's going to be adjacent over opposite, or 12 over 5. And that's all there is to this one. Super easy, right? Let's go to the next problem. This I think is actually a pretty easy segment of this particular lesson. All right, so here we're missing a side. You're going to use Pythagorean theorem to find your missing side. So add this part to your notes. I already put it up there. And add all the notes there. This time I'm not going to write opposite, adjacent. I don't have it written down. I just have the ratios. And so everything you see up here, you should write in your notes as well. All right, so we have hypotenuse squared, which is 5 squared, equals leg squared, 4 squared, plus, and then we're looking for the other leg. We can just call this one x here. Don't worry about the y there because we're not looking for the angle measure. So 25 is equal to 16 plus x squared. Subtract 16 from both sides. And then we have 9 equals x squared. Take the square root of both sides. Notice I use the principal root only not to be confused with solving a quadratic equation. Quadratic equations have 2 solutions. The side of a triangle cannot be -3. So this one has 1 solution. And x is equal to 3. Next thing we need to do is label the sides of our triangle relative to our angle. Right? Our angle is right there. This one is a y instead of a theta. Oh, actually, I guess I should make it a theta, huh? Since I put theta next to all of these, let's just make it a theta. There we go. Let's call it theta. All right, so relative to theta there, our opposite is at 3. So this is the opposite. 4 is the adjacent side, and of course, opposite the right angle is the hypotenuse. Sine is opposite over hypotenuse, so that's going to be 3 over 5. Cosine is adjacent over hypotenuse, so that's going to be 4 over 5. Tangent is opposite over adjacent, so that's going to be 3 over 4. Cosecant is the reciprocal of sine. And some students say, well, why isn't secant the reciprocal of sine? Because they start with the same letter. Well, they're not. Right? Secant and cosecant, they have other meanings as well. But so cosecant is the one that's the reciprocal. So you can just remember that the letters don't match. So sine and cosecant are reciprocals, and cosine and secant are reciprocals. But tangent and cotangent sound like they go together, and they do. So the cosecant is the reciprocal of sine, so that would be 5 over 3. Secant is the reciprocal of cosine, so that would be 5 over 4. And then cotangent is the reciprocal of tangent, that would be 4 over 3. And so you should know it as the reciprocals, and you should also know that, for instance, cotangent would be adjacent over opposite. Secant would be hypotenuse over adjacent, and cosecant would be hypotenuse over opposite. Right? So you should know them by which sides they use, as well as the fact that they are reciprocals of another trig function. I think maybe there's one more. This is a shorter podcast. That's good, because last one was 31 minutes. All right, so this one is a 30, 60, 90 right triangle. All right, so we're not going to use any Pythagorean theorem here. Instead, we're going to use our relationships. All right, so this is the short leg. How do we know that has to be the short leg? Well, if this is, the triangle has 180 degrees, right? So if the one angle is 60 degrees, that means this angle has to be 30 degrees because the other one is a right angle. And so that's 150, and so there's only 30 left. All right, so opposite the the smaller angle is the short side. Opposite the 60-degree angle is the long leg. And of course, the hypotenuse is opposite the right angle, right? So what we know is the short leg, right? So now the short leg is equal to, actually that's, sorry, no, the short leg. The hypotenuse is equal to the short leg times 2. All right, so that means that hypotenuse here is equal to 2 times 7, or 14. Add this to your notes. And then we need the long leg. The long leg is equal to the short leg times the square root of 3. And actually, I'm going to put the square root of 3 afterwards, because we would write the number, and then we'd write the square root of 3 anyway. So the short times the square root of 3. So the long leg is equal to 7 square roots of 3. See, pretty easy. All we need was one side. All right, so now let's fill in the rest of this here with our ratio. So sine, oh, we didn't label opposite and adjacent and hypotenuse. Well, we did label hypotenuse, but not the other ones. A here, I don't know if you notice it, that is our angle of reference. So 7 is the opposite. The short leg is the opposite. The long leg is the adjacent. And of course, hypotenuse, always opposite the right angle. So sine is equal to the, and maybe on this one I'll write it out. Sine is equal, and I'm going to abbreviate though. So sine is equal to the opposite over the hypotenuse. And maybe you write it out too, just as a reminder. So our opposite side is 7, and the hypotenuse is 14. Why didn't I label the triangle too? So this, let me just label this. So adjacent, and actually I'll label it in this color. So this is 7 square roots of 3, and this is 14. So I'm not looking all over for the numbers. So this would be 7 divided by 14. That reduces. We need to reduce that to 1/2. Cosine is the adjacent divided by the hypotenuse. All right, so the adjacent side is 7 square roots of 3. The hypotenuse is 14. That's going to reduce as well. 7 and 14 reduce to 1 and 2. So now this is going to be the square root of 3 divided by 2, because we don't need to have 1 times the square root of 3. Tangent is opposite over adjacent. All right, so the opposite side, opposite A there, is 7. The adjacent side is 7 square roots of 3. We could reduce, cancel out the 7's there, right? And that's going to give us 1 divided by the square root of 3. But we have a radical in the denominator. So we're going to have to multiply by the square root of 3 over the square root of 3. So that's going to be 1 times the square root of 3 or the square root of 3. Square root of 3 times the square root of 3 is the square root of 9, and the square root of 9 is 3. So hopefully you don't mind if I just do that. Cosecant is the reciprocal of sine, which means it's going to be hypotenuse over opposite. And it's going to be 14 divided by 7, which is 2. Secant is the reciprocal of cosine. So it's hypotenuse divided by adjacent. So that's going to be 14 divided by 7 square roots of 3. We could reduce the 14 and the 7. So that's going to give us 2 divided by the 3. And again, we need to rationalize. So we're going to multiply numerator and denominator by the square root of 3. 2 times the square root of 3 is 2 square roots of 3. Square root of 3 times the square root of 3 is square root of 9. Square root of 9 is 3. And there we go. And that is all nice and simplified. Right? And then finally, cotangent. It is the reciprocal of tangent. So it is the adjacent divided by the opposite. Our adjacent side is 7 square roots of 3. Our opposite is 7. We don't need to rationalize because the radical's in the numerator, but we do need to reduce. And this is now the square root of 3. You don't need that 1 in the denominator. And that's all there is to these. So now we have done the second page of notes. Whew. 2 pages done. And this is your whiteboard practice. What I'm going to let you do, I'm not going to have the problems necessarily on the Nearpod to fill in. I'm just going to have just question to just kind of make sure that you have an understanding. Instead, I'm going to print this out, and you and your partner can work on these problems whenever you are ready. All right? So that's the end of this podcast. Thanks for watching. Bye for now.